Welcome to Unit 1, Section 3, Notes and Examples. This is interval notation and set notation. This might be the first time you're seeing this. If not, that's okay. This will be a very easy review. So let's go right into Section A, bounded interval on the real number line. So we need to write the bounded interval in interval notation. So for notes, if you'd like to write some in the bottom, if you have any inequality that is not underlined, you're going to use parentheses. If you ever have inequalities that are underlined, you're going to use brackets. So the parentheses means the number is not included because we are not underlined or not equal, and the brackets mean that the number is included because it's less than or equal to or greater than or equal to, which means we can be equal to the number, so we have to include it in our answer. Now, one thing to note on the parentheses is anytime you have infinity, it is always parentheses because you can never reach infinity, therefore you can never include it. So, looking at number 1, we have one that is not underlined, one that is underlined. And when we write these, the interval notation, we don't include x, we just want the numbers. The inequality symbols let us know whether we use a bracket or parentheses. So on the first one, because it is not underlined, I'm going to have parentheses and the smaller number 2, always put a comma, and then the larger number 9, and because we are underlined, I'll use a bracket. And that's my answer. That's all we're doing. Let's do it again on number 2. So number 2, I now have underlined, not underlined, or equal, not equal. So same thing. The underlined one on -10 means that we use a bracket and write -10, comma, the higher number, -4, and because we are not equal, parentheses. And that's your answer. And that's all we're doing on A. Let's move down to 3 and 4. Now we need to graph the bounded interval on the real number line. Notice we have the same inequalities as above, but now we just have to graph them. So again, for some notes, anytime you have inequalities that are not underlined, we're going to have open circles. Anytime we have inequalities that are underlined, you guessed it, closed circles. Because again, open means we are not including that number, and closed means we are. So looking at number 3, since we have a number line with no numbers, I can write these numbers anywhere I please. So I'm going to go ahead and just write 2 right here, which would make 3, 4, 5, 6, 7, 8, 9. I always write the numbers first, but you don't have to. That's okay. So notice 2 is not underlined, so 2 will get an open circle. 9 is underlined, so 9 will get a closed circle. And notice how x is in the middle. So all we do is connect these dots, and I always use a squiggly line, especially if you're using a pen or a pencil and a black pen at that. It matches the number line, so just to make sure I know exactly what I'm doing, I always just use a squiggly line. Or if you just want to use a different color, whatever works for you. And that's our answer. So moving to number 4, underline, not underline. And again, write the numbers first if you'd like. -9, 8, 7, 6, 5, -4. So -10, because it is underlined, will get a closed circle. And -4, because it is not underlined, gets an open circle. And x is again in the middle, so we connect our dots, with the little squiggly, because they're so much cooler than straight lines. Straight lines are boring. And that's our answer. Alright, moving on. Section B. Now we have unbounded intervals on the real number line. So we just want to write the unbounded interval in interval notation. So again, the interval notation still applies from above. Parentheses are not underlined and brackets are for the inequality symbol. Only this time you notice we have an x, an inequality, and a number. We don't have two numbers. That's okay. Now you got to be very careful on which side the number goes on, because making it unbounded means one side has to go forever without stopping, or infinity or negative infinity. So if you look at this first one, I have x is less than or equal to 6. So if I start at 6 and I'm less than or equal to 6, that means I can be any number less than 6, which means 6 will be my highest number that I get to, because I don't go over that. So I'm going to put a comma in the front and put negative infinity. So unbounded means I start at one number and I go one direction, either positive or negative, towards negative infinity or positive infinity. Once I have my setup with my number and my infinity symbol, I can add my parentheses or brackets. Now, if you remember from above, infinities always get parentheses because we can never include something that's not a number. Infinity is not a number, so always remember that. But if we notice on the 6, because that is underlined, the 6 would get a bracket. And that's our answer. Now let's look at number 6. We have x is greater than negative 3. So now we're greater, negative 3 would be our smallest or our lowest number. So I'm going to write negative 3, and because that's our smallest number, I do comma, and we go forever above negative 3, or towards infinity. Now, because negative 3 is not underlined, we're going to use the parentheses on the left, and infinity is always parentheses on the right. And that's our answer. Pretty simple. Okay, the next one, number 7. Now we want to graph the same inequalities or intervals that we just did. So again, we have an empty number line. We can put that number anywhere we want. So I'm going to put it right in the middle. You don't have to if you don't want to. So we are going less than or equal to. So because we are underlined, I have a closed circle. And if x is less than, I wouldn't be going up. I'd be going down, which is to the left. So from my circle, I'm just going to go down forever and ever and add an arrow on the end. The arrow just simply means that I'm going to keep going past the end of this number line because I don't have a number I'm going to. But that would be my entire graph, and that's my answer. Moving over to number 8, I'm going to go ahead and write negative 3. And because I am not underlined, I will have an open circle. And if x is greater than, I would go above or to the right. So squiggly arrow. And that's my graph. Hopefully these aren't too bad. But if you ever have questions, you can always ask away. Alright, final section on this is set builder notation. So we want to write the interval or set in set builder notation. So before we get to that, let's just add this on the bottom. Set builder notation looks like this. We have a fancy bracket, the letter X, a vertical line, and then depending on what we have, we would either have some number less than or whatever, less than or equal to x, and then less than or equal to b. So that's one version. Or we could have the fancy bracket, x, vertical line, and then x is either greater than, less than, depending on what numbers we have. So those are our two versions. Now this would read on the top, I would have x such that, that's what that line means, a is less than x is less than b. Same way on the other one, I would have x such that x is greater than a. So that's how you would read that after you write it. So let's go ahead and do these. There's only two. So notice we have the set of all numbers less than or equal to 10. So notice we have one number, and if we only have one number, it's going to look like the second one down there. So we always start with fancy bracket, x such that